The Sun is a giant sphere of hot hydrogen at the center of our solar system. Inside it, thermonuclear fusion is taking place, producing enormous amounts of energy. Some of this energy reaches the Earth, mostly in the form of ultraviolet, visible, and infrared radiation. Approximately 1,360 watts of energy falls on 1 square meter of the Earth's upper atmosphere. This figure is called the solar constant. Much of the radiation is reflected by the atmosphere, but a staggering 3,400,000 exajoules still hit the Earth's surface every year, more than 7,500 times the current energy consumption of humanity. The energy of the Sun has been used by people since ancient times. The simplest way was to build your dwelling so that the midday sun would warm it. The innovation of glass made it possible to exploit the greenhouse effect. Visible light passes through the glass and heats the objects. These generate infrared radiation, but the glass no longer lets it through. The heat stays inside. The warmer environment in a greenhouse allowed more delicate crops to be grown, higher yields, but also quite simply the opportunity to enjoy exotic tropical plants. Simple devices called solar collectors work on the greenhouse principle. The Sun heats the inside of the glazed collector, which is fed with air, water, or a heat transfer medium. Solar collectors are used for indoor heating, domestic hot water, or as part of a heat pump. Sun-oriented houses, greenhouses, or solar collectors have no moving or electronic components and are therefore collectively referred to as passive solar systems. Active solar systems increase the efficiency of energy harvesting by using various electromechanical devices. Solar thermal power plants concentrate the sun's radiation to a small point, the same way a magnifying glass does. The temperature of the focal point reaches hundreds of degrees. There are different types of concentration solar power plants: central tower solar power plants, parabolic trough collectors, and parabolic dish concentrators. A central tower solar power plant concentrates solar radiation into a single point using heliostats. Flat mirrors are arranged around a central tower and rotated by computer to reflect the sun's rays into the receiver on the tower at every moment of the day. The high temperature reached in the focal point can be used directly in the so-called solar furnace or to warm the heat transfer medium. This energy is converted into electricity in the steam cycle. A parabolic trough collector consists of an array of parabolic troughs. At their focal point is a long tube through which the heat transfer medium flows. The trough rotates behind the sun to make the most of its energy. A parabolic dish concentrator consists of a large parabola that follows the sun. Temperatures of up to 700 degrees are reached at the focal point of the parabolic mirror. This energy is often harnessed by the Stirling engine. Smaller versions of parabolic concentrators can be used to heat food. Thermal solar power plants have the advantage that the heat energy produced can be stored, for example in a molten salt tank, and used later, such as at night. A special type of solar power plant is a photovoltaic power plant. It harnesses the energy of incident photons and converts it directly into electricity. A photovoltaic panel is a semiconductor, most often silicon-based. A p-n junction is formed at the junction of two layers doped with, for example, boron and indium. The incident photons knock electrons out of the crystal lattice and accumulate in the n layer, creating a voltage between the p and n layers. Large arrays of photovoltaic panels are capable of producing huge amounts of electricity. Solar energy is free and available over the entire surface of the Earth. It is an environmentally friendly and renewable resource. Its disadvantage is that it's only available during the day and during clear sky conditions. In addition, the amount of solar energy incident per unit area varies with latitude and season. In winter, solar power plants produce significantly less than in summer. To make solar energy available all year round, it is necessary to store it in times of surplus, either in batteries or as thermal energy in molten salt storage tanks. Regardless, solar energy has a large potential because the Earth's surface receives 7,500 times more solar energy than is the consumption of the entire human civilization.